Hello, 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 my studious calculus students. We're on question number 7 of our sort of mock midterm or midterm test question bank. And what have we got? Cos of 2 tan to the minus 1 of x. And remember, just as I mentioned last time, tan to the minus 1, we would be more familiar with it, if you've been coming to our class, as arctan. They mean the same thing. I cannot stress this enough. It's just a difference of notation. Just like y prime means the same as dy by dx. Some mathematicians prefer arctan, some mathematicians prefer tan inverse. Okay? I don't control which ones are on the midterm. I really don't. Okay? Some of the other calc profs like tan minus 1 and hate arctan because there's extra writing. And I appreciate and understand that. But we need to be comfortable with both of them. Just like we need to be comfortable with different forms of the line. In class, we mostly use point-slope form of the line because it's really easy to answer our questions with point-slope. But there's many students out there who have said, gee, I really wish we could do more y equals mx plus b, y-intercept form. Well, there's some profs who like that, some profs who like point-slope, and it depends on who's writing the midterm as to which one pops up more frequently. Okay, but we need to be ready for both. Anyway, getting back to question number 7. Cos of 2 tan inverse of x. Well, that's a bit of a mouthful. And if I take a look at my answers, it looks very similar to, if you remember when we did derivatives of inverse trig functions. That's a fairly recent thing. We had to work out things like cos of arc sine of x. And it sort of reminds me of that, these answers that we're getting out. I mean, that was, what? Root 1 minus x squared. I'm seeing 1 minus x squareds, 1 plus x squareds, all that sort of stuff. So, do I have to do special triangle sort of stuff? And absolutely, that is a way that you can do this question. That's the way I choose to do this question. You might have another way to do it, in which case, that's fantastic. But this is the way I typically do this question. And I break it down. Cos 2 tan inverse of x is a bit of a mouthful. Okay? So I'm going to simplify this just a touch. Okay? And what I'm going to do is I'm going to say, well, let's let tan inverse of x. So tan takes in an angle and spits out a value. Tan inverse takes in a value and spits out an angle. So I'm going to use a customary angle notation for theta, and I'm going to say tan inverse of x is theta. Now, either I apply tan to both sides, or I just rearrange the expression. That means tan of theta is x. Okay, it really does. Just apply tan to both sides, and you'll see. Okay, so this is some nice information that I've got. Tan of theta is x, and this will help me set up a triangle. But look at what else this has done. The question was asking us for cos of 2 tan inverse of x, but that's just cos. Oops, handwriting has gotten small. But that's just cos of 2 theta. And you might say, well, what can I do there? I think this was question 1 or question 2, but double angle formulas again come to our rescue, and we get cos squared theta minus sine squared theta. Okay? So what do I need to do? I need to take this information, tan theta equals x. I'm going to create a special triangle. From that, I'm going to get sine, I'm going to get cos, I'm going to square them and take the difference. Okay. So now, tan theta. What does SOHCAHTOA tell us about this? Well, it tells us in a right angle triangle, it's opposite over adjacent. So here's my opposite, here's my adjacent, here's my hypotenuse for angle theta. So opposite over adjacent is tan of theta, which is x. Now this isn't a fraction, but I can turn him into a fraction, x over 1. And so now my opposite value, I'm going to make that x. And my adjacent value, I'm going to make that 1. And then, yeah, opposite over adjacent is x over 1, which is just x. So we've used our piece of information. Now, what else can I do? Well, I want cos and sine. Well, cos is adjacent over hypotenuse, and sine is opposite over hypotenuse. So in order to calculate either of those, I really should have my hypotenuse value. And to get that, I'll just use the Pythagorean theorem. It says that my hypotenuse squared is my opposite squared plus my adjacent squared. Rearranging those quickly, my hypotenuse is the square root of x squared plus 1. So now this triangle tells me sine theta is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And now this comes together in simplifying cos squared x minus sine squared x. I get 1 squared over the bottom squared minus x squared over the bottom squared. Just gets rid of the square root sign, really. Now, since we have the same denominator, we'll make it 1 minus x squared over 1 plus x squared, and we are done. Now, was that one of our possibilities? Yep, it was right there. It's B. All right. Up next will be question number 8. If you haven't given it a try, I encourage you to do so before watching the next video.